This conference will now be recorded.
We'd like to welcome everyone here to our March Lunch and Learn. And this is going to be an excellent class. This qualifies for 1 hour core, which for plumbing and for your contractor license. If you're watching this or viewing it at a later date, you need to make sure that you send me your information, your license and name, so that we can ensure that you get the credit. Would like to also let you know that we have our annual conference coming up in April 22nd and 23rd. We have some excellent classes. We have classes that will just be on benefits. So for those people who are responsible for your benefit programs in your company, might want to attend the afternoon, Thursday afternoon. There is going to be excellent vendors, exhibitors, demonstrations, and so it'll be an excellent conference. It would be nice to get out and start networking. As you see, the state of Utah is starting to open up, and with the requirements that Thanksgiving Point has given to us, we feel like we can do this safely, and we're looking forward to having this at Thanksgiving Point. So it's going to be closer to the majority of our members. So there should be some great involvement and from everyone. So we're looking forward to that. But I would like to turn the time over to Wes Lovell. He is part of the Lovell Company. They are an excellent member. They provide sponsorship money to the association and very supportive of the association. So Wes, I'll just turn it to you to explain a little bit about your company, as well as introduce our guest instructor.
Great, thanks, Dave. So yes, I'm Wes Lovell, and as part of the Lovell Company, we represent Rheem Manufacturing in Utah and Southern Idaho. And everybody's pretty familiar with Rheem, but we are a full line tank and tankless manufacturer, both electric and gas. And I'm happy to introduce Brad Davis today. Brad works for Rheem as a national plumber support manager based in Denver. He's been a third generation plumber for over 30 years. Plumber, Pipefitter, Steamfitter, and HVAC supervisor. He's also a licensed master plumber in Colorado, looking to extend his license to Utah, actually. We're just talking about that. Yeah. And I'd also like to point out that he is a U.S. Navy veteran. And I think I'll turn the time over to Brad, unless there's anything else I can add.
Well, thank you, Wes. Thank you very much, sir. Guys, I appreciate all of you taking the time today. I know these continuing education credits are very important for us as plumbers to be able to continue our licensing. I did just apply for my Utah master's license to see if I can join the club up there and maybe get into some trouble with you guys up there in Utah. Again, I do appreciate y'all taking the time this morning. Again, my name is Brad Davis. I'm the National Plumber Support Manager for the Mountain Region and the West Coast for Rheem and Brood Manufacturing. Really, my experience is over 30 years as a service plumber, whether it's residential or commercial. I did everything from digging up sewer lines to replacing steam boilers. So really, I've got a vast, wide variety of experience. So I appreciate y'all. Again, to talk about really today's classes, I want you guys to understand that this is intended as a training aid. All operations can vary from manufacturer to manufacturer. So really, when we're talking about multimeters and manometers today, every manufacturer is going to have a little bit of difference in their nuances on how they operate. So really, if you have any questions, go ahead and feel free to unmute your mic, hit me up with any questions as we go through this, okay? Let's start off with multimeters. So really, what does a meter measure? You know, a meter, that's whole job is to measure whether we're talking volts, amps, really ohm meters, really anything that measures resistance or voltage and amperage. You know, a multimeter is really going to combine all of these functions and possibly others into a really compact unit. I know, guys, I've got a wide variety myself of different manufacturers of different multimeters. Every one of them does something a little bit differently. And really, it's your choice with whatever piece of equipment that you're comfortable with. So we'll be going through really a basic one today. But when we're talking about a multimeter and what she really measures, I want you to understand that we're looking for voltage, or we're looking for amperage. We're looking for a type of resistance and a type of test for continuity. You know, every function on a water heater is going to come down to one of these most likely at the end of the day. Now let's talk about a couple of these real quick. You know, Ohm's law. Ohm's law says that the current in a conductor is directly proportional to the voltage across it and inversely proportional to its resistance. I know I just said a bunch of big words. I'm a plumber. So really, is the question. So let's make it even easier to understand, okay? In layman's terms, this means that the more voltage will produce more current if resistance stays the same, all right? But the higher the resistance, it will cause the current to decrease if the voltage stays the same. I know I did it again. I've got guys scratching their head, and I understand it. Again, remember, I'm a plumber, so if you have questions, hit me up. We're not expected to be electricians as a plumber, so make sure to hit me up with any of those questions as we go, okay? Now, make sure we're on the right one. Now, electricity. I want you guys as plumbers to really think of electricity as working with water, all right? That's the easy way for us as plumbers to understand it. The pipe size equals resistance, or ohms, okay? Then we have the water pressure. That's going to equal voltage, you know, if we're looking at it in plumber's terms. And that water flow would then be that amperage, all right? So I hope you all understand that we're looking at this in plumber's terms as pipe size is resistance, or ohms, water pressure is voltage, and our water flow would be that amperage. So when we look at a simple circuit, when the circuit is closed, that means that the electrons are flowing from the negative to the positive, and it's working. When the circuit is open, there is a break somewhere, right, guys? When that circuit's open, there's a break. If it's intentional, like a switch, then everything is fine. But if that break is unintentional, then this is where a multimeter comes in handy to find that fault, right? Because we got to see where that circuit is open. So let's break down that multimeter real quick so we can look at testing for voltage. The biggest thing I can tell every plumber out there, every apprentice that I talk to, when you're not using that multimeter, make sure it's in the off position. The last thing you want to do is show up to that job and have your batteries dead in your multimeter. I carry spares with my kits, guys, so it's advisable. If you're using a multimeter, make sure you carry spare batteries in case you leave this unit on. LED displays, depending on the type of unit you're going to have, are going to read in different settings on the meter, whether it's voltage on AC or DC continuity, your positive jacks, your ohms, and of course, in a lot of instances with water heaters, we use DC voltage, okay? You're going to see different front panel symbols. They're all going to be the same from different manufacturers. You know, your volts DC and your volts AC are going to be the same. Your millivolts readings, your amps, your milliamps, all of that is really going to have the same symbols regardless on the manufacturer that you have, the manufacturer's meter that you have. We're going to have all sorts of different symbols for diodes, hertz, you know, whether we're looking at seeing highest settings on voltage, you know, a lot of different things, guys. So really become familiar with your piece of equipment that you're using. The selector switch, very easy. That, you know, guys, we always start in that off position. And remember to turn it off, okay? I can tell you, as a plumber here in Colorado for over 30 years, I can't tell you how many times I've turned on my meter and found I had a dead battery. That's why I stress that so much, guys. So there's different types of probes or leads that you can use with your multimeters. You know, a standard one is usually the probe that comes with a meter. You know, you really would need to order or purchase your additional alligator clamps. I know some manufacturers require that as an additional purchase. I like the needles, the standard needles that come with it. You can get even finer points to test those even smaller circuits, okay? The gripper, I personally use this a lot, guys, when I'm out there in the field, especially when it comes to testing zone valves or components within a furnace cabinet or a boiler cabinet. To use a multimeter as a voltmeter, it is connected in parallel between the 2 points where the measurement is to be made. Very basic. The voltmeter provides a parallel pathway, so it needs to be of a high resistance to allow as little current flow through it as possible, all right? And this will make a little bit more sense as we go through it. So remember, we've got DC voltage, which is your AC voltage, which is your alternating current. That's basic elementary school science class, right? Your alternating current describes the flow of change that changes direction periodically. As a result, the voltage level also reverses along with the current, all right? So it's an alternating current. AC is used to deliver power to houses, offices, etc., guys. Really, that's our main one in your home. Now, direct voltage, DC voltage, is a bit easier to understand than alternating current. Whether that it oscillating back and forth, DC voltage provides a constant voltage or current like a battery supplies and thermocouples, all right? That's really where we use it a lot in the water heater world as plumbers. Now, you can select AC or DC, depends on the power source which you're testing, okay? Now, the probe leads are to be connected in parallel, all right? Be very careful not to touch any other components within that equipment, and don't touch those metal tips together. It's not going to help it. You're not going to get a reading, okay? Now, when we're testing as a voltmeter, okay, you can use the positive probe to check areas along the circuit to determine where along the line there might be potential problems. We're going to show you how to do that. Simply testing it at your battery to verify that you have the voltage, which on this battery, we are currently pulling 8.7 volts, okay? And we're on a DC volt. So you can use this to verify that you have power. Now, the current is the rate of flow of charge, and the manometer measures the flow. You must not be connected directly across the voltage power source, since the internal resistance is low and the excess current would still flow. Okay, so really in layman's terms on that, when the amperage range is greater than 1 amp but not less than 10, the positive probe will need to be in the 10 max jack setting on your multimeter. Okay, higher end multimeters can go greater than 10 amps. Just the one that we have on the screen, the one that we're using today, has a maximum of 10. So when you're using this as an ammeter, make sure to turn the power off before connecting the meter, okay? Break the circuit and place the multimeter in series with that circuit. Select the highest current setting and turn the power back on and work your way down. Turn the power off and disconnect once you get those readings, okay? So right now we're trying to read that we're getting those, that circuit is completed. That's what we're really essentially testing, is that this meter is in series with that circuit. Make sure that you turn the unit off when you're not on that one. Now, using it as an ohms meter is a little bit easier. This was the first thing I was taught as a plumber, learning how to test circuits and test equipment, was I was able to test it in ohms. And I still do it today, 30 years later. Make sure that the power's off to whatever you're testing before you try and test a current as an ohms, okay? The component has to be removed from the circuit. For an example, if you're testing out, say, an element out of a water heater, you want to make sure that the water heater is off and you've disconnected the wires from that element to be able to test ohms and make sure that that circuit is complete. So we always start at the lowest ohm setting, or maybe even the highest, depending on what you're testing, okay? Now, the component can be measured, or the component being measured needs to be removed. As I had mentioned, guys, take those wires off of that circuit. Disconnect that component that you're testing. Then you're able to test that circuit for ohms. And really, as a layman's terms, I used to always tell my apprentices, it's a beep or no beep. It's either going to beep or it's not going to beep. It's either going to be a complete circuit or it's not. Okay. Now, if we're testing and looking for specific current ohms, you can also do that by checking that highest setting on your meter. Okay. Very simple. Continuity is the presence of a complete path for that current flow. Okay. So there's no breaks in that flow, right? That's what we're looking for. Now, what if the cable might be bad? You want to check to see if there's a break in that line. How do you do it? Very, very simple. You know, that's the biggest question. How do I see if there's a break in that line? So let's bring it back up again. Again, you can use the positive probe to check areas along the circuit to determine whether the line there might have potential problems. And that's what we're going to do. We really need to test it. So to test the multimeter, there we go. Sorry guys, technical difficulty there. Had another screen pop up on my screen. Test the multimeter continuity by touching the two probes together while you're in that continuity, that beep or no beep setting, right? Now, if the cable is good, there's going to be a beep. You know, if you're checking that wire and you've got a lead on both ends, it's going to beep, and that's going to tell you that there is a complete circuit. Now, let's look at a basic wiring diagram. Okay, now we're talking about a water heater, the basic water heater, an electric water heater, and the basic circuitry in it, okay? You'll notice that you've got your line voltage coming in, okay, your 220 or 240 volt coming in. That power is getting distributed down to that upper and lower thermostat, as well as that upper and lower elements. Now, the following test should be done with the power turned off at the breaker and then the wiring disconnected from the element or the thermostat. This is exactly what I was just talking about, guys. I want you to be able to test that element on that electric water heater. If the element is good and that continuity is there, there's going to be a beep on that element, right? I mean, because we've got a closed circuit. Now, if that element, goodness, if the element is good, you're going to get that beep, guys. Now, if you're looking for specific ohms, turn this over to your ohms selection and be able to see the exact resistance or ohms on that individual element. It's very easy to do. Take the time and make sure that the unit is off and you disconnect the wiring from the thermostat and from the line voltage to that element before testing it, guys. I can tell you many, many times I have plumbers calling me saying that they have a bad element. So I have them verify and test it. And they test it with the wires still connected, okay? We're not getting proper readings. So we want to check the resistance. So resistance measuring on an element. If the resistance measure is below 10 ohms, that element's going to need to be replaced, right? Because we have the most resistance from 10 to 16 ohms. So if it's below 10 ohms, that element's going to be bad. All right. And I test so many elements on a regular basis as a service plumber. Having the guys be able to do this correctly is going to save us all, including yourselves, a headache. Okay. Proper testing. Now, let's check continuity on, say, that upper thermostat, because again, this is very important when you're troubleshooting. If the upper thermostat is good, has good continuity, there's going to be that beep. And again, guys, make sure that the wiring is disconnected. Okay. If there's no beep, test the multimeter again. And if there's no beep at the thermostat, it has a break and needs to be replaced. It's really that easy. Now, we're going to show you that you use those two upper left-hand points to be able to test that element, or the thermostat. And guys, sometimes you may need to turn the thermostat dial up or down, depending on the temperature that thermostat or that thermistor is at this time. Okay, take your time and go through those little tests. Now, still looking on that upper thermostat, we're testing the other side, the right side of that thermostat, where it's going to push the power down to the lower side. Okay, you can test both of these, and you want to test these both sides, again, while that power is off. And it's just a matter of getting right on those screw heads, guys. Okay? I don't need you to get underneath to the brass plate. I just need you to be on that screw. Okay? The screw that you loosened up, you didn't take it all the way out, you just loosened it up to remove that wire so you could test the thermostat, right? Now, we continue and do the continuity again on that lower thermostat. Guys, I use beep or no beep a lot, especially for my younger apprentices and my younger plumbers who may not do a lot of troubleshooting. Beep or no beep is a good one for them. That's why I have it on here. If that lower thermostat has good continuity, there's going to be a beep, okay? As long as that circuit is closed, the thermostat's calling for heat, okay, you're going to get beep. Again, you may need to move that thermostatic dial, the temperature dial on that thermostat to be able to open and close that circuit. I do it a lot, guys. I test it both ways, both open and close. I want to make sure I have a beep and I don't have a beep, that thermostat is actually functioning to the dial, okay? Now, let's talk about some electricity warning. The following test should be done with the equipment on, all right? So this is where you're starting to be careful because we have power to it. And again, we're plumbers, okay? So we want to check voltage on that upper thermostat. We want to verify that we've got 240 volt AC. Now your multimeter is going to need to be placed in that 600 setting AC voltage, since the current being measured has a potential to be greater than 200 volt AC setting, okay? We don't have a specific setting on a lot of meters for a 240 volt, so always go higher, okay? If you know your voltage that you're looking for is higher, definitely go higher on your meter, okay? Now, if the upper thermostat has power, those two terminals up at the top are going to have 240 volts, okay? Very easy thing for us to read, very basic. Now, the reading does not measure. If it doesn't measure that, you want to go back and check on your wiring and maybe get an electrician back at the breaker if you're having issues further back, okay? Because again, we are plumbers, mechanical contractors. Now remember, I'll say it again, your meter should be in the off position when not using it, okay? It's a big deal. Now, that's really the basics of a digital meter and how a circuit is. Feel free to take more classes and get more information on your electrical side and troubleshooting. I know I offer them here. I know your group up there in Utah has a lot of great courses available on that electrical side. Let's talk a little bit. If y'all don't have any questions, let me know if you do. Feel free to unmute yourself at any time. Let's talk about manometers. Now again, these are basics for troubleshooting water heaters, all right? And again, all of this presentation is intended as a training aid, okay? Again, device operations will vary from manufacturer to another. Always, always, guys, and I don't believe I said it at the beginning of this, refer back to that manufacturer's use and care manual and their service manuals prior to doing any work or troubleshooting. Make sure you know the piece of equipment that you're getting ready to test. It'll help you for sure. Now, again, this is third-party products. Every one of us out there have probably a different type of manometer that we use. This product that we're using is the HT1890 manometer, and it's available from various manufacturers of this version. Again, operations of this equipment can vary from one to another. Heck, I think out in my truck, I have 3 different manometers, 3 different manufacturers' manometers. So really, guys, make sure you know your piece of equipment. Now, what does a manometer measure? Really, a manometer is a handheld instrument designed for measuring the pressure of gas. All right. I know I still have my old liquid units where I could test gas pressures, so this is kind of taking me up into a new game. We want to be able to measure positive and negative and differential pressures in gas. Excuse me, guys. Look at your model's manual to be able to figure out that unit range and selectable in various unit measurements. We've got a lot of things we can measure with these manometers. Some of the basics is measuring gas pressures gas pressures in inches of water column or feet of water column depending on the size. We can even go down to the centimeter of water column with some pieces of equipment. Personally, guys, I've used maybe a handful of these functions over the last 30 years, or actually last 15 years since I started going digital. All right. So you'll find what's more fluent or what you use in your area more often. And depending on your skill set as a plumber as well, depending on how far you go into it. A lot of mechanical plumbers, mechanical contractors get into it a little bit more. So make sure you know which ports of your meter are going to be your negative and your positive. That's going to be vital for you to be able to do your testing. And also what range and differential mode that you want the unit in. Your screen is going to be very different, again, guys, depending on the manufacturer. So I'm just showing you a basic of what mine reads. All right, very basic. Now, what can a manometer help with? Really, pressure. We know that basically pressure influences whether the liquid or gas being measured can enter or exit the object being measured. For example, your gas valves. That's what's most important to us as contractors is making sure that we have proper gas pressure and gas flow to meet the BTU need of that specific piece of equipment. Manometers measure that differential pressure or the difference in pressure between 2 points for diagnostic reasons. Really, I need to know my pressure drop, I need to know dynamic pressure as well as static pressure. So can the static or dynamic pressure, and both can be tested positive or negative. All right, we can see that pressure drop positive or negative using a manometer. Now, pressure drop only occurs in a flowing system in a downward direction. So as long as that gas is flowing through that component. Now, dynamic pressure results from the liquid or gas being in motion. All right. So while that valve is open and running, you've got flame on that piece of equipment, that's where you're getting that dynamic pressure. While the static pressure is when that component is sitting there idle. There's no call for heat. Okay. That's when that static pressure is not moving. Now, what can be measured on your average water heater? Because that's where most of us plumbers run into it, is we need to know and verify. And I know up there in Utah, this is very important with our ultra low NOx products. Okay, we need to make sure we have proper gas. So testing that incoming gas pressure through a sediment trap is how I do it on a residential water heater. All right. Because these gas valves do not have the taps on them for us to be able to test these pressures on your average residential water heater. So I really do that by going in through that sediment trap. I created and purchased a cap with a barbed connector on it, so I can attach my tubing from my manometer, making it easy to be able to test gas pressures on a residential system just by using that sediment trap cap. Okay. I know it seems a little bit out there, guys, but it was the easiest I found and the quickest way for me to be able to get into this. Now, we recommend using a 1/2 inch end cap to start, or you could even use 1.5 inches to start and use reducers to go down to 1/2 inch, which is common. And that's what I did. I used a larger cap, and then I have several bushing reducers, so I can bush it down to, say, that 1/2 inch or 3/4 inch standard sediment trap, right? And then I used a barb fitting and I threaded it into there. So I had to tap and drill it in there. So I get that right, 1/8 inch hose setting or 1/4 inch hose setting on there for my manometer. And as an example, this is how I do it. I really just take that sediment cap off and I attach my cap with my barb fitting in there. That way I'm able to see that static and dynamic pressure of gas going to that water heater. You'll be able to see it very closely right here. Now you'll see that I hook up my manometer right to that barb fitting. I make it easy so I don't have to do a lot of deconstruction of that gas piping on that system, as long as the plumber ahead of me installed the product properly with using this sediment trap. All right, I know in Utah, this is just as important as it is for me here in Colorado, that we have the sediment trap before that gas valve. All right, now we want to measure that gas pressure in a high H2O setting. Okay, so when you're looking at that gas valve, that digital gas valve, okay, we're trying to test what that static and dynamic pressure is for that type of valve, right? That's basic on a ULN water heater. Now, we can do this on the bottom of this valve. There's an inlet pressure tap. Okay, so if you don't have the cap and hosing available, you can also do it from this valve. All right, this is very specific. Now, you can take that plug and remove that Allen wrench. It is very important that you shut the gas off to this unit just to verify that there's no gas leaking while you're doing this. Okay, you get your barb fitting connector out of your bag and you thread that end up and screw it into that port. Again, we're looking at measuring static and dynamic pressures. So attach that tubing from the manometer right there to that barb fitting on that gas valve. Guys, is my opinion on some plumber. This is the more difficult way to do it, all right? Not all of these gas valves are the same. And again, every manufacturer has their differences. So being able to do this right at that sediment trap ensures that I can test any equipment, all right? Again, we're measuring that gas pressure in H2O. Now, pressure through the gas valve. Really, that's where you're gonna see that dynamic pressure, all right? Use that manometer to check the typical flow or the capacity versus the pressure drop. That's what you're gonna be testing at that port. You're really just looking for that flow versus pressure drop, okay? Now, when we talk about different tankless systems, on the bottom of a tankless unit, you can locate that gas inlet port. Now, some manufacturers will replace or place a port on the bottom to test gas pressures because, again, checking gas pressures on a higher efficiency piece of equipment is more critical, all right, on how that piece of equipment operates. In this picture here, you can see that the gas port is covered by that sticker and can be easily taken off. You know, guys, really turn the knob, the gas off going to it, and then loosen that screw just a few turns. Again, don't remove that screw completely from that port because all you need is that gas pressure to push through there, that gas pressure to escape, okay? Here's a close-up of that type of a system. We want to turn that gas off to the unit and loosen that screw and put our hose onto that screw and carry different sizes of hoses with your manometer, guys. I know I've got 3 different sizes I carry with mine just because every manufacturer varies, okay? But really, you can set it on this port and be able to check that static pressure on that unit, all right? And you'll be able to also measure the pressure drop from right there on that unit, from static to dynamic. All right, guys, so really that comes down to our basics of this unit. I would like to go back just a little bit and make sure that we understand how we're making that connection on a standard residential unit. Myself and my plumbers here in Denver that worked for me before I retired, this was the setup we used on every residential unit. And guys, I'll tell you, up there in Utah, where you guys are working with ultra low NOx products, you need to pay attention to our gas pressures coming into that unit and make sure that they are adequate for running. All right. Most problems with our ULN product come down to low gas pressures. All right. Your ultra low NOx burner is a lot more susceptible to faults due to gas pressures. All right. A lot of our equipment, I try to tell my plumbers, you want to see no more than 1.5 inches of water column drop from static to running. Okay. Make sure that you take the time, if you're having issues with that residential unit, make sure you're checking these gas pressures as you're going through it, whether you're utilizing it through that sediment trap like I do, or if you're using that digital gas meter on that ULN product and being able to test it right through the valve. All right, many differences in different manufacturers. A lot of manufacturers are going more and more to this digital valve where you see the blinking LED visibly as it's operating. That's where the federal government is going more and more, is they want a visible signal that this unit is operating. Now, remember, check your static and your dynamic pressures. All right, we need to know what that pressure drop is, especially if you're having combustion or ignition failures. All right, whether you're utilizing a tank or a tankless product, gas pressures are very important, especially when it's ULN related. Now, I like running my equipment and testing everything to measure that high and low pressure, or that static and dynamic pressures. Guys, regardless of the manufacturer of unit that you're testing or the unit that you're utilizing, okay, make sure you're capturing those numbers. If you are calling onto any manufacturer's tech support line, this is one of the first things they're going to be asking you on a gas piece of equipment when you're having combustion failures. So I hope I've put enough information out there not to give you a headache, but to pique your interest to join us for more and more classes to be able to get those continuing education credits. Please hit us up, guys. I appreciate everybody. Does anybody have any questions? And how are we doing on time? It looks like I've got a little bit of time left, so we can take in some good questions if anybody's got any. Again, I do work for a manufacturer, but I am licensed here in Colorado as a master and working on my Utah license, thanks to David and the guys over at Level. How we doing, Dave, sir?
Excellent presentation. Thank you. It was very well organized, and we appreciate it very much. Again, does anybody have any questions?
I see Gary up there. Gary's been paying attention through the whole thing. Even though he had to check his mail, he was still there.
All right.
Hey, you got to do what you got to do.
Absolutely.
Hey, the rest of us are here too. We just didn't ask questions.
Well, guys, I appreciate
I
everybody.
don't know if you remember, I did have some of your guys' training. We've called a couple of the big heaters. So we had a quick Zoom meeting, about a year ago.
I think I do. I think I do remember that, Gary.
But we had to crane them up on a roof.
Ah.
I'm trying to think, is it Phil? Or who's I don't know, he was my contact with you guys.
We've got Tim Scott and Jeff Haney. They work a lot up there in Utah. There are engineers. Were our engineers involved?
Yeah, but I don't remember the guy's name that I dealt with most of the time. Well, actually, Pew's.
Oh, Rodney.
Yeah, Rodney. Yeah, there you go.
I just talked to him this morning. I'm one of our high efficiency condensing guys at Rheem. So Rheem really does ask our contractors to get involved. We really want that plumber who is installing the product to let us know what they're running into in the field. And Rodney and the guys you know, our engineers at the factory, they're so involved in everything that we do as plumbers. If you didn't know, about 5 years ago, as a manufacturer, they changed their whole outlook on who they were selling to. Now, which is big to me as a contractor. And they took it more as, we need to focus on the plumber. Instead of focusing just on the product all day long, we're focusing more on listening to the plumber, seeing what the guys are needing out there in the field. So pay attention to what's coming forward in this, the end of this first quarter. At least I hope it comes that quickly, because we've got a real great solution to the ULN, I won't say issues that all manufacturers have had, but the speed bumps that we've all went through with the ULN product. We've got a new unit coming to you guys specifically that is going to solve that for you guys. So keep paying attention to us. I know as a plumber, I'm very involved with research and development at the manufacturer level, which is so different than what I've seen as a contractor. And Gary, you know, by working with Rodney and the guys and Wes, it's all about taking care of that end user. But at the end of the day, I got to make sure that plumber is perfect. You know, that plumber needs are fulfilled, you know.
Well, that's the thing you guys did for us before we installed those. You guys wanted us to do the Zoom, so we, you know, I brought all my guys in and we did a 3-hour Zoom meeting and did a quick little training. Gave us a heads up before we installed them to make sure we flued them right and that we used the right gas regulator and all that kind of stuff. So it was good.
Excellent, excellent. I like to hear that kind of stuff. It really is making sure that the equipment is installed properly. It doesn't matter the manufacturer. Again, I've been in this industry 30 years. My dad retired as a vice president at Ferguson, so I've seen product after product, you know, changing and evolving so much over the years. Utah has it the best way, where you guys require people to take these classes. And again, I can't say enough about it. From looking outside in, I wish my state did it. I wish we required our plumbers to stay on top of the innovation and the product that's out there. It's so key. Even something as basic as troubleshooting has changed so much over the years. Heck, you get your average residential service guy, he's not going to know how to test gas pressures on a water heater. But you get your mechanical guy, and he goes, "Oh yeah, I'll do that. I can make something up. I can do it." So we're trying to equal out the playing field, making sure that our plumbers are stepping up their game. I mean, honestly, if we're not staying on top of our game as plumbers, we're falling behind.
Right.
But no, I appreciate you. If you need anything, you've got our contact info, Gary. You can reach out to me at any time, especially when it comes to product related. I am getting more involved in Utah, thanks to David and the guys over at Level. So hopefully you guys will be seeing me around more and more. And I can't wait to travel again. My gosh, I can't wait to. I never said I would miss an airplane or a hotel, but I actually kind of miss an airplane and a hotel right now. I think my wife says the same thing, that she wishes I was on an airplane or in a hotel again.
Well, very good.
I've been home this much in my whole life. 30 years, you know, my wife and I are going on 25 years together, and I've never been home this much. Oh.
Well, thank you, Brad, very much for the class. Justin, you're online. I don't think I have your license number. Would you make sure you send me your license number via my email?
Yep, I'll get it.
Okay, because I want to make sure
you know, your business license and your
yes, your contractor license and your plumbing license. Because
Firstborn child, everything else in between.
yeah,
right.
because these live webinars give you credit. You have to have, with your contractor license, you have to have 3 hours of live in the seat class with this type of involvement with the instructor. So this class qualifies for that, but if you watch this as a video, then that doesn't qualify for that 3 hour requirement. So just these lunch and learns become even more important. So anyway,
Okay,
thank you, everybody. And I think I've got everybody else's contractor licenses and plumbing license, and we appreciate it. And just remember, we've got our conference coming up on April 22nd and 23rd. We've got some good CE classes, and for those of you who are owners of your companies and so forth. So thanks a lot, everybody.